Before we show you how to model your reflectance sensor attachment for your robot, I thought I'd give you some thoughts on modeling the reflectance sensor holder in terms of the design process that you're going to go through. The first thing you've got to do is consider about 4 different factors. The first being the size of the sensor. That's important because you need to attach it somehow, and therefore you need to know how big it is. You need the effective height of the sensor above the surface. That is, how high above the surface does the sensor need to be able to pick up the difference between black and white. You need to figure out how you're going to actually attach your holder to the robot. And you need to think about 3D print size factors and other 3D printing related factors, because 3D print is going to be your manufacturing process, and you need to understand that process to most effectively design your 3D printed part. So you might be tempted to go out and get the calipers out and start measuring your reflectance sensor as you go. But before you start measuring any component that you've bought from a shop, it's probably a good idea to check on the internet to see what that will look like, because they might have some information that will help you. And sure enough, I went onto the Pololio website and found that particular link. And somewhere on this page, you need to read it all very carefully, I found a DXF file with measurements. And a DXF file is a type of image file. You can open it in Illustrator, or you can open it in Fusion 360, and it shows you the measurements of that particular device. Even better though, and that's what I'm going to use in my demonstration, I actually found a 3D model that actually works and is the right size. So they've actually gone to the effort of creating a nice little 3D model so that you can put it in your 3D environment and model it up, which is fantastic. So let's use that. You need to find those yourself. They are on that web page. You need to read through and look for them. Now, the effective height above the surface for the light to be able to pick up. Now remember, we're only using an analog signal, a digital signal, and this is an analog receiver. So if you look on the one on the right, that does give us a signal, and we could measure it at 3/8 of an inch away from the surface. Whereas this one here gives us a pulse on a spinning disc, by the way, a pulse of a nice, almost binary looking type. So it almost looks like a binary pulse. So we probably really need to go closer to this number than to this number, which basically translates out to about 3.4 millimeters. So we need to be closer to the 1/8 of an inch on the left than we do to the 3/8 of an inch on the right, which is about 3 to 4 millimeters. But having said that, you will get better results if you show that you have experimented with the height at different heights and given different results. So measured some sort of results, done some sort of experiment, measured some results, and discussed those results to actually inform your design. And you need to consider different surface types in your results as well. For example, glossy versus matte. We use a semi-gloss matte to actually practice with our robots, but what if you were using a printed piece of paper, which is fairly flat surface? So you need to be aware of those experiments, and they should impact your design as well. So you also need to consider things like whether you're going to have one on the front or the back, or you're going to have them both on the front or both on the back, how you're going to actually arrange that, and you need to use experiment to be able to achieve that. Attaching it to the MR5 is a fairly simple sort of concept, and that is that we have 3mm drill holes that we can use. Those 3mm drill holes are along the front and along the back of your robot, depending on which you call the front or the back. But on either end, there are a whole bunch of 3mm drill holes. They are 10mm apart. And we are going to use M3 screws and nuts, and we have varying lengths of those. So we're going to use M3 screws and nuts. The 3D print size factors are sort of important for you to understand, but basically Any object needs to be 3 millimeters or greater in thickness in order for the 3D printing process to actually get you the strength that you're going to need. If you go less than 3 millimeters, you find that your parts start to get a bit flexible and more liable to snap or break. You should also remember that they are weak along the layers, just like wood is weak along the grain. 3D print is weak along the layers. So you need to design and print your item with the layer lengths in mind. And you should always print with support removal in mind, because if you try and print something that requires the printing to work in midair, it will build a sort of scaffold up to that height, which you'll need to remove away. And you'll see what that means when you start actually doing some 3D printing. The final thing you should consider, which is not a 3D print factor, but the acrylic or the laser cut acrylic, is prone to stress fractures. In other words, it snaps. And that can be from impacts, and those impacts could be transferred through the 3D printed parts. So you need to consider the design of your 3D printed parts in a way that they may be able to transfer stress along a greater surface area than just a single point when you're basically using your robot. So here I am working in Fusion 360. The first thing I'm going to do for this is I'm going to start a new project, and I'm going to call that new project Student Robot. If you don't know how to get this panel up, it's by clicking this little data panel button here. So I'm going to call this Student Robot and hit enter. That's going to create that project. And now I'm going to double click into the Student Robot. I have got a lot of projects. And in here, I'm going to go straight away and save my design, which will be called Reflectance Holder, and hit save. So that's now saved in a folder called Student Robot, and it's called the Reflectance Sensor. The next thing I'm going to do is I'm going to upload the 3D model, which I downloaded from the internet, from the Pololi website, so it'll be in downloads, and it's called a step file. Here it is, the QTR1 reflector sensor step. I'm going to open that up, and that's going to upload, and I'm going to click upload. That's going to take a bit of time to upload, and I've done it before, but you can see I'm doing it now. So it's going to take a bit of time, so I'm just going to pause while that happens. So that's still going. It's going to take a while for that to actually render in their system. Their system has to basically do some work on it while it's there. So let's just get going with a rough shape of what I'm going to be doing anyway. So basically I'm going to be creating a side profile of my particular holder that I'm going to create. It's a very basic holder. It's just going to be a basic C shape. I'm going to do a side profile. So I'm going to click on this plane here, and I'm going to draw a side profile sketch of my plane here. Now if you like the grids, you can turn the layout grid back on like that. And I'm going to go across here, and I'm going to go across here about that far, down about that far, across here, and you can see I'm drawing a reversed sort of C shape. Let's zoom in a bit and just keep on drawing my lines around with the line tool. And you can see there that I've drawn a slightly angled line there. So let's fix this up now. I'm going to fix that first angled line up by using the constraints tool, and I'm going to use the horizontal constraint. Hopefully you've watched a few of my videos to see that how I can do this. The next thing I'm basically going to do is I'm going to set the measurement, and the measurement I'm going to set with a D for dimension is going to be this measurement here, and this measurement here is going to be 10 millimeters, and that's the bit that's going to sit underneath my robot with the hole drilled through it. So that's going to be 10 millimeters, and remember my dimension here, my minimum dimension I want is 3 millimeters for strength. If you go too much more than that, you're going to have trouble putting a hole through it. Sorry, not a hole through it, but a screw through it. So 3 millimeters is probably good at this point. I'm also going to set the distance between this line here and this line here. I'm going to make that maybe 4 millimeters just to make it a little bit stronger in that length, because that's the length that's going from the top. This is the robot here, so the robot plate will be here, and the sensor is going to go down here on the ground. And I'm going to make this dimension here a little bit thicker, so I can put a screw into it. So I'm going to make it maybe 6 millimeters thick. And finally, what I'm going to do, just to make this sit nicely, I'm going to use the coincidence tool here and here. So that puts that in place. What I really need to finally do is get a dimension of this length here. Now I don't know what it's going to be, so I'm just going to say it's 45. Yours can be the height that it needs to be to get your sensor to be the right height off the ground. So that's what I've got, and if I hit stop sketch now, you can see that I can look at this sketch in 3D, and it's not much at the moment, but I'm going to click modify, and I'm going to pull that sketch out, and I'm going to pull that sketch out to be, let's just go out 20 mils, well, we'll go 15 mils. So I've got 15 mils of going out there, and I can basically now put my holes through, and I need 2 holes through this section here so that I can attach it to my my robot. So I'm going to press circle tool, so sketch, circle, center diameter circle, and I'm going to draw it on that surface there. So I'm going to draw 2 holes on that surface there, one here. They're going to be 3 millimeters. Remember, the holes are 3 millimeters, and a circle here of 3 millimeters, and I need them to be 10 millimeters apart. So let's make them 10 millimeters apart, and you can see that's pretty close there. So now I need them probably from about here to about here. I need that to be maybe 3 millimeters. This one here to this one here, it's going to give me an error. That's going to be 2 millimeters. So I can just press OK. I can't change this one, but I can change this one by double clicking on it and going 2.5, and that will update, and now there's a nicely in the center. And maybe you could go a bit wider with that first extrusion, but 15 millimeters is the narrowest you'd want to go. I need these to line up now, so I'm going to use the constraint tool, the vertical horizontal constraint. I'm going to click on the center of that circle and the center of that circle, and that makes them, or forces them to be in line. I'm going to do the final one, which is the diameter from here to here, which is going to be 5 millimeters, and that will line them up perfectly. I'm now going to press stop sketch. We're going to look at that from a different angle. There we go. I'm going to use the modify button. I'm going to select both of these and just drag this down through until I'm sure that my hole is drilled, and that's going to be how I'm going to attach it to the top. So basically, how do I get it onto the bottom? How do I connect my sensor onto the bottom? Well, I'm actually going to go over this sensor over here now that it's imported, and go right click and insert into current design. I can only do that because I've saved it, but it's going to insert it into the current design. It's going to spinny wheel for a bit while it figures out how it's going to do that. And it's going to do it somewhere. There it is, up there. And it's going to have these arrows on it. These arrows instantly allow me to move it around. So let's just move it down. And we'll move it around. And you can see that the sensor bit, the black sensor bit, it actually looks exactly like the thing. The black sensor bit is up the wrong way, so I can grab this circle here and rotate it around 180 degrees. And you can see the 3 holes there are probably in the wrong spot for where I want them, because I want them sort of sticking out here. So I probably need to rotate them with this one maybe. Yep, that's the one, around 180 degrees. And now I'm just basically going to maneuver this until I'm happy with its location. So let's just pull that down there and zoom in a bit. So if you zoom in closer, you can move it slightly better each time. Now I'm going to move it roughly to the middle, and I'm going to press OK. So that's where it is. Oh, hang on, I didn't move it in the right dimension this way, so I'm going to press the move tool. And I'm going to move my mouse over until I get a nice position for my handles. And I'm going to move that till it's actually sitting inside in here nicely, but I can still access these pins because these holes will have pins sticking up. So there we have it. I'm going to press OK now. So that's the sensor. That's where the sensor is going to go. So what I'm going to now do is I'm going to use that sensor to do a subtraction. Let's do that now. So I've got mine up here, but you go modify and combine, and I need to capture the position. That's just basically saying you've moved this thing. Can we use it where it is? I'm going to go and select my target body, which is my holder. I'm going to select my tool body, which is my sensor, and I'm going to use the cut method or cut operation, and I'm going to make sure keep tools is selected or was selected. I'm going to press OK. So now if I turn my tool off by pressing this little light here, you can see I've left behind in the bottom a couple of nodules in there. So now all I need to do to be able to get this to screw in the right spot is to be able to use the circle tool again. Actually, I won't use the circle tool. Instead, I'll press O for outline or offset. This one here, offset. And I'm going to offset. And I'm going to select the outline of that. And I'm going to set the offset position to 0 and press OK. So now I have a sketch on there that I can actually push through. Stop sketch. I can now use the modify button. Press and pull that all the way through. And you'll notice that it's actually going to come up. Yep, there. I don't need to go all the way through. 6mm should be okay. So now I've got a little hole there. I probably should get rid of that little guy there. So let's just do the same thing. This time I'm going to use a slightly different technique. I'm going to draw a sketch. And instead this time I'm just going to press P for project. And I'm going to click somewhere in the middle. And that's going to turn that whole surface into a sketch. And I'll click OK. I'm going to go stop sketch. And then I'm going to modify that down. I'm going to modify the whole thing properly down. No, cancel. I modified the edge. If you modify the edge, it does the wrong thing. Modify the whole face so that it's down to there. There you go. It's pretty close. I'm going to press OK. So it has a little mark there, but that won't print because the resolution's not that great. So that's where my basic thing is going to sit. So my sensor will sit in there nicely. Final thing I'm going to do, just to finish it off, is to put some fillets on. The fillet tool is a modify tool, and it's F for fillet. So I usually use the F tool. And putting rounds on things, just a small round, will actually make them stronger. Even though it's less material, it will make them stronger. So I press F for fillet there, 2mm, and I can just keep going around until it looks nice. That is your very basic technique. If you want to put some text in there, you can use the text tool. It's in the sketches, and that's basically all I'm going to show you how to do. That will hold the sensor to your robot. I'm not sure if the height is right, but that will hold the sensor to your robot. It will print very quickly, and it'll just get you going. There will be cables coming up here. You could use a cable tie tied onto that. But basically, that's all I'm going to show you how to do in terms of connecting it to your robot.